Hello, today we're looking at a question from paper 1 in the TMUA in 2020, and this is question 4, so towards the start, so hopefully not too difficult, hopefully approachable. Let's see what it talks about. The first, second and third term of a geometric progression, or a geometric sequence, are the first, fourth and sixth terms respectively of an arithmetic progression. And then it says the sum to infinity of the geometric progression is 12. Find the first term of the geometric progression. So keeping in mind that for TMUA, there's no formula book that's going to tell us the sum to infinity of a geometric progression, or arithmetic for that reason as well. So we have to keep that in mind, that we need to remember these things. Okay, so here's our potential answers down here. Let's have a look here. So the first, second and third terms of a geometric progression. So we can write down that it's AR, the first, the second is AR squared, and the third is AR cubed. And it says the first, fourth and sixth of an arithmetic progression. So the first, I've done these powers wrong. This should be 0, 1, 2. There you go. So in other words, this R to the 0 is just 1. So we've got, it's the first, fourth and fifth. So A equals A is not very informative for the first. The fourth though, AR to the 1 equals A plus 3D for the fourth term of the arithmetic progression. And then it says the third term equals the sixth term, which is A plus 5 times the difference. So now we've got two equations here. We've got AR equals A plus 3D, and we've got AR squared equals A plus 5 times the difference. And also we've got the information, the sum to infinity of the geometric progression is 12. Well, the sum to infinity is A over 1 minus R equals 12. In other words, A equals 12 brackets 1 minus R. So now we have three equations, 1, 2, and 3, with three unknowns. And the one we want, the one in the question is A. We're trying to find the first term. Okay, so it seems reasonable then to take the first two equations and try and eliminate D. So we can do that by multiplying the first one by 5. So 1 times 5. If we do that, we're going to get 5AR equals 5A plus 15D. Take the second one and multiply it by 3. You get 3AR squared equals 3A plus 15D. And once we get to that stage, we can subtract one from the other. So let's do that. 5AR minus 3AR squared equals 5A minus 3A, which is just 2A, and the 15D's cancel. And then, interestingly, even though we're trying to find the A's actually cancel here as well. So we're going to have to find R first. So what have we got left? We've got 5. Well, we've got R lots of 5 minus 3R equals 2. And then we can, or rather than do, let's not do that, that's not helpful. We've got a quadratic in R, haven't we? So let's just rewrite it. It's 3R squared minus 5R plus 2 equals 0. This will factorize 3R and R equals 0. 2, we want to end up with minus 5, and we need both the signs to be the same. So that's going to give it this way round. We need minus 5. That will give us the minus 5. So R equals 2 over 3, or R equals 1. We need to choose which common ratio is the correct one. Well, don't forget, if it's going to sum, if it's summing to infinity, it needs to converge when we know it converges to 12. But the rule is, the condition is, that R has to be, the size of R has to be strictly less than 1. So that will not work. So we're taking R as 2/3. R is 2/3. Well, we can just put it back in here. If we're putting R in here, we can say A equals 12 times, well, 1 minus 2/3 is 1/3. 12 divided by 3 is 4. And that's going to be our answer 4. Let's see if it's in the list. Sure enough, it's here. And we're done.